In this episode, I finished the encoder mount for my electronic lead screw conversion. Welcome to another episode. In this episode, I'm going to make a few other attempts to try to get things set up with the electronic lead screw encoder mount. And I finally settled on a design that is the final design, I promise, both to myself and to you. And it's working, which is really cool. So let me take you through the process and show you how I got to where things are at now. While I was waiting for the pulleys from Masumi, as well as the one from that I ordered from Amazon that I believe is coming from China with a larger bore, I learned about these pulleys on another site, which is STP SI. And I ordered these pulleys less than a week ago, and as you can see, they're already here. They don't have a flange like the other ones do, but the important thing is that this one right here has a large enough flange on the outside here that I should be able to bore this out and use shorter set screws and put it on the outside of the tube of the spindle, and then that should all work. And as you can see, I also have the belt, which is great. So got all of this in less than a week. I've taken the set screws out, so now I'm just going to put it in the chuck. Okay, and make sure that that runs smoothly. I'm going to start, see if I could start with a 1/2 inch drill, which is the largest that I think will fit into my tailstock. So I'll get that up and close. And then slow this down. Let me try 265. Okay. Okay, so we're at 0.86. I just want to check that every now and then. Okay, so I'm seeing 1.24, 1.025. So I need about 10 thousandths, so I'll do 5 thousandths this pass. Okay, and then measure it again. Okay, so we're about 1.033. And the target, as I said, is 1.035. So yeah, I'm going to let this cool off. So I took a spring pass, and I thought I was recording, but I wasn't. But I'm going to take this out now and then test it. There's a burr on the back here, so I'm going to get rid of that first. I'm just going to... Okay, let's see how I did. Okay, I think there's a little bit of a burr on here. So let me see if I can find a stone and stone that off. Let me open the door, that'll make it easier. Okay, yeah, it does kind of fit on there, but it's a little too tight. So I'll take another spring pass and see if that makes a difference. So I did two things. One is I stoned this a little bit more because I could feel a burr along here. And then the other thing is I did a spring pass, and now it fits on there very nicely. So I got some M4 by 6 set screws that will fit in there like so. And I measured this, and it's just a little bit more than 6 millimeters. So that means that this should, helps to have the M6, the correct wrench for the M6, which is M2. And as you can see there, that's perfect. I did have some shorter ones, but I think the 6 millimeter long set screws will be just perfect. So now I can and that's running nice and true. Perfect. Okay, one of the things I realized looking at this is that I want this to be sticking out a little bit more, because what I'm hoping is I'll have enough room between here and here so I can put the bearing for the other pulley right there, and then have the other pulley reversed. I'll show you what I mean in CAD. So what I'm going to do is I'm going to pull this out a little bit, like about so, and see if it continues to run nice and smooth, or I should say concentric. There's a little bit of wobble, but it's not too bad. So I'm seeing if I can get rid of the wobble. Yeah, now that's running nice and true. That I'm pretty sure is sticking out more than I need it to. So that's sticking out almost 12 millimeters. And I think I need about 8 or 9 millimeters, so this will work just fine. All right, I'm going to put this back on the back here. Oh yeah, I have to take this off first. Okay, that's going to work nicely. So let me line these up and grab the correct Allen wrench. Make sure that's it's wobbling a little bit, so let me see if I can fix that. Okay, now I should be able to adjust this. Oops. Okay, I'm seeing that it's walking back, and I think the reason it's walking back is, let me show you, let me bring you around. So the issue is that there's some raised lettering here, and this is perfectly flat here, but this is slightly proud of this surface here. And so what I need to do is redo this a little bit so that there's room for this to sit flat, because it's not sitting flat right now. Yeah, and I think what I'm going to do is try making the insert that I have in here just a little bit thicker, and see if that does it, so I don't have to reprint this part. So I've doing some more testing here, and I'll show you what I discovered, which is that basically, depending on the angle here, I can make it walk one direction or the other. And so what I'm realizing with that is I probably need to create some jack screws on here that allow me to adjust this just a little bit so that I can get it aligned so that it doesn't move back and forth and doesn't rub against the plastic. I mounted the new version that has 2 jack screws on this side. I discovered I didn't need them on this side, just this side. So I've adjusted them a little bit, and you can see this is running fairly true. It's tracking pretty well. And if I move the screw, it moves to one side, and if I move it the other way, it moves to the other side. So I have really fine adjustment now on the tracking, which means I can get it centered like I have it now, and it just sits there. So I'm pretty happy with that result. This is running at 1400 RPM, and that's 2800 RPM. Which is pretty fast. But I think that's going to work just fine. So the next step is for me to attach the encoder and hook it up to the ELS 4 basic. All right, I have what I need to be able to assemble this now. And the first thing is to put this is a spacing tool. So they say to put that on there. And then I'm grabbing the right one for here. And then this goes on next, using this tool here. So it says to press the shaft adapter over the sleeve until flush with tool A. So I'm pressing down, and now that's firmly in place. And then the next step is to take this here, and again using this, I guess, to center it. I'm not quite sure how that works. Let's see. Let me put this on here and see if I can understand how that works. Okay, yeah, there's a centering boss there. So what I want to do is basically bring it down like so. There's some, there we go. And then this is a push fit into here. So now this is in place where I need it to be, as you can see. For my particular case, I want this to be 400 pulses per revolution, and so these switches need to be changed. Right now they're 000, and I need 0110. So I need to go in here and push these two switches up. So now it's 0110. And now it's ready to go on here. So this should just snap in place now. I have it hooked up now, and I can already see one change that I want to make, which is down here. I want to extend the 3D printed section here so that it supports the circuit board. And so I can clamp the circuit board in place, because with the cable coming out the back, there is room for this to wheel around, which could be a problem. Now the next thing I want to point you to is right up here where it says U. I'm going to bring you in closer in a little bit, but right now I'm going to make it so that you can see pretty much everything. So if I grab onto this, you can see this is now rotating. And this says it's about 70 RPM. Now if I turn this on, let me change this to a slow speed, so it's 65 RPM. And you can see this is saying 69, so that's pretty close. And let me bring you in closer so you can see this section here. Okay, this is a little closer view, and again, watch this. So that is saying 69, and now I can double the speed, and it's saying 140. So this is running a little bit faster than the speed box says. Now let me change the gears to 265 and run that. So that's still running a little bit fast, but the point is, it's working. I took the set screws out of this pulley that I'm going to bore out, and now what I'm going to do is I'm going to put these copper protective pieces on the jaws, so that I can put this in here without marring the pulley. There we go. And then I'm going to put some parallels in here so that I have room behind the pulley to be able to have the boring bar come out behind. There we go. That looks good. Make sure it's tight, but not too tight. And I'll take a preliminary measurement, but I'm pretty sure I have about, let me find out. It's pretty close to the diameter. So it's saying 0.9775, and the target is 1.033. So I have 58 thousandths to go on the diameter. So I'll take a little bit more off. And then I'm going to use the snap gauge to measure after this pass. Okay, so I'm at 1.009, and I'm pretty sure I want to go to I'm called at 1.01. I want to go to 1.033. I forgot to deburr this while it was in the machine, so I'll just do a quick deburr here with the Noga tool. Okay. So it's pretty close. Okay, that's not a bad fit. It's not quite as tight as I would have liked, but I think it'll be fine. So I'm going to put the set screws in and give it a try. Well, that's running nice and true, so I'm happy with that. I'll bring you in closer in a minute, but this, I believe, is the final version of the spindle encoder mount. And if you look right here, you can see as I spin the spindle, the number starts to change, and if I turn it on, you can see that it counts up very nicely. You can see a better view here. I've got the two pulleys with the belt, and the encoder is sitting right in here. The encoder is held in place, and this retainer holds this in place. So this is all very sturdy. And then I've got a clamp on the end here so that the board that is connected to the encoder is also held firmly in place. I'll bring you around so I can show you that. Here you can see the back and how this is held firmly in place. The other thing that I'm going to put on is this cover here, which will cover the belt and protect it nicely. And here you can see it is with the cover. So there's a hole in the cover which allows me to use the through spindle. So if I have a rod that will fit all the way through here, then it'll just come out the back. And it still works just fine. So I'd say that's all done, and now I can move on to the lead screw control itself. I want to show you one of the interesting features about this, which is something they call the angle function. So right now, when I turn this is showing RPMs. But if I press the right, it changes the cycle, and one of them is going to be angle. Angle. So you see right there it says 56.92, and so as I rotate this, you can see the angle is changing, and I can move this ever so slightly I'll have to do some calculations to figure out what the accuracy, or I should say the precision of the angle is, but you get the idea. So if I want to set this to 0, I just move this around, and there it's on 0. And now if I move this right here to about 45 degrees, let me go the other, actually I meant 90 degrees. It's right there. So one of the things that means is if I wanted to use this for dividing, I could. I'm not sure if I will, but I thought it was an interesting function, and one I'm going to have to think about how it might actually be useful. So this is working really well. I'm very happy with the results. The very next thing is going to be to set up the stepper, the hybrid stepper motor on the lead screw. And once I have that set up, then I'll be able to actually use this as a lathe using the electronic lead screw to control the feed per revolution instead of the gears on the back. So I'm really excited for the next step. The step after that is going to be putting a stepper motor on here, which will then allow me to do automatic screw cutting. So that will be able to control both the lead screw and also the cross slide. And that's going to be really exciting when I get that. I hope you enjoyed this episode. Please subscribe, give me a thumbs up, comment below, and if you've already subscribed, make sure that you hit the bell icon so that you're notified when I have a new video. See you next time.